I feel it in my data. I see here what it shows. The stats are all around me, and so the knowledge grows. It's written on the screen.
It was another busy day at the Tiberit Company. Everything seemed normal, when young CEO Stanislav received a call from an important customer, absolutely shocking him. That is why, among many other things, Tiberit is a supplier of newly designed valves for coolant circuits in portable HVAC units. And Stanislav just got told that 10 HVAC units were accepted for warranty repair due to malfunction of the valve. As the valve did not close properly, the coolant from the engine was still warming up the heat exchanger, causing a hot air coming from the unit when it was supposed to cool the air down. The internal scrap rate of the valves was about 0.3% of the leakage test, and as it was a 100% check, none of the leaking parts should have made it all the way to the customer. The leakage measuring unit was, of course, the first that came to mind to blame.
Something must be wrong with the fully automated measuring device when it let the leaking units pass.
The gauge was using air to measure the possible leakage, as it was reliable and reasonably inexpensive method time-proven on many past projects. And, as everyone would guess, if it's airtight, it surely must be watertight too. Per the archived gauge reports, the measuring device was what one would find capable.
In cases like this, we cannot be careful enough. We should rerun the gauge capability study to see what exactly has changed and what is wrong with it.
To everybody's astonishment, there was nothing wrong with the gauge. It was as good as when it first started in Tiberit. The repeatability and reproducibility all was okay. Could it be that somebody readjusted the pass-fail criteria? The simple experiment with coolant showed that one valve that failed with coolant passed with air. The air-based criteria must clearly be too loose. It could not have been anything else. The Tiberit renowned experts checked, inquired, and inspected everything they could, and this was the only explanation. But how to set the pass-fail criteria? It was time to call Jaroslav.
Karl Popper once wrote, "Whenever a theory appears to you as the only possible one, take this as a sign that you have neither understood the theory nor the problem which it was intended to solve." And now to your valves. This is a task that must start with the design of experiments. The air and the coolant may have different interaction with the tested parts, so it is necessary to take a set of parts and measure it with the air, after several open-close cycles, and at different coolant temperatures.
The effort paid off. In one day, sufficient correlation was found to hand over the new criteria. But what could have changed since the gauge was installed? Changing the tolerances must be well verified, and it was quite suspicious to see it changed. And so Jaroslav repeated the experiment the second day, again producing a new pass-fail limit. What no one expected happened. The two experiments resulted in significantly different criteria. Clearly, there was something very strange going on.
To have a different model every day does not make any sense, and it only underlines the fact that we do not have any model at all. There must be some other explanation.
And so, A slightly extended experiment was performed the third day. Only after making a meta-analysis on all the collected data, it surfaced that there is not a reliable dependency between the air test and the coolant test. The amount of both, the false positive and the false negative results, would be far too much for the acceptable risk.
So all the air gauges used on similar projects are failures?
Let's check the data first. Let's do some mining.
Soon after reviewing the quality data history, the problem localized only on the one new valve design. The design was using a novel actuator-driven flap that was supposed to carry the orifice. This flap, made of plastic, was particularly sensitive to the passing media, and it behaved very differently in the air and in the coolant. It was different to the degree that parts that were airtight could have been leaking the coolant, and parts that were coolant-tight leaked the air.
To sum it up, the gauge, which was believed to check the tightness, was not actually functioning at all. It was simply sorting the valves to OK and not OK bins without relation to their real function. When starting a new project, one has to make sure that the measurement design relates to the manufactured design.
It was a crucial moment when Jaroslav handed over the displeasing report containing the disturbing findings backed by the collected data. What will Stanislav do? We all know how this usually goes. Such report must be kept secret, and no one must ever find out, least the customer. But not in Tiberid. Stanislav soon called a kick-off meeting of the task force team, which faced the problem bravely and honestly. Everyone makes mistakes, and Stanislav knew that the customers will always value those who deal with the mistakes more than those who try to hide them. So, one problem was successfully solved, but so many others were to come.